In example 7, we have another multivariable function to optimize, but in this case, our work in part B, finding those critical points, is going to be a little bit more involved. We'll start off by finding the first partial derivative with respect to x will give us y minus 8x minus 3, and m sub y will give us x minus 2y plus 1. To find the critical points, we'll take each of those expressions, set equal to 0. And solve. The trick now is that we have two equations, each with two variables, meaning we're solving a system of two equations with two variables, and we need to use elimination or substitution in order to solve this system. I'm going to use elimination, and in this case I'll multiply the first equation by 2 to get 2y minus 16x minus 6 is equal to 0. The second equation will remain unchanged. And we do that so that when we add these two expressions together, 2y minus 2y cancels out, and we're left with minus 16y plus x, or minus 15x minus 5 is equal to 0. From there, we can solve for x, and we would get x is equal to negative 1/3. Once we have that value, we can go back to either of the original equations. We'll plug in our value for x, which was negative 1/3, and solve for y from there. So we'll get y is equal to, not y is equal to, we'll get y plus 8/3 minus 3 is equal to 0. 3 is the same thing as 9 over 3, if we write that as an expression with a common denominator. So we get y is equal, or y plus negative 1/3 so y minus 1/3 is equal to 0, or y is equal to 1/3. That means we have a critical point at negative 1/3, comma negative comma positive 1/3, and we'll test that using the second derivative test. First, we'll find each of the second derivatives. M sub xx will be negative 8, m sub xy will be 1, m sub yy will be negative 2, and m sub yx will be 1, meaning d will be equal to negative 8 times negative 2 minus 1 times 1, or 15. That result is greater than 0, meaning we have a local maximum or a local minimum. So we check the second derivative with respect to x, m sub xx, which is equal to negative 8, which is less than 0. That tells us that we have a local maximum at negative 1/3, comma 1/3.